Okie dokie. Let's see how this goes. Oh, I think we might be online. If someone can let me know, or once someone comes on, if the audio balance is right, I'm going to do some work assembling MEGA65 expansion board here today. I'll get a bit more light on me here too, I reckon. Let's see how that goes for us. Now, just let folks know that we're streaming. Oops. Hopefully this won't cause feedback initially because I'm just pulling up the URL here. Okay, cool. I will. Hey! Welcome whoever's tuning in. If you can just let me know what the audio level is like for the music versus my voice, that would be fabulous. How is the audio level of music versus my voice? Cool, and hey, Hiramari. So I've got my soldering iron warmed up. Bit of background here. Now I'll just see if I can get the, once I stoop down to solder, I'm going to be lower down on here. Yep, that looks all right, I think. So what we have here is an expansion board for the MEGA65, so prototype of that. So I've already loaded in a bunch of, so actually we'll go around that way, a bunch of the 1K resistors that I'm going to solder in a minute. So this board has user port. That's the analog video port, that's the Commodore 65 disk drive port, and that's the tape port. And then there's kind of pass-throughs for the internal floppy drive and a few other bits and pieces on there. So yeah, we'll go through. I'm just going to turn the music down a fraction because I'm actually having trouble hearing myself think actually. Let's see if we can. Yeah, I reckon that might be. That's better for me anyway. Let me know if the music's too quiet now. So yeah, chuck any questions in you have about the board as we go along. Otherwise, it'll be a few minutes of me soldering away happily while I get these 1K resistors on before we move on to the next bit. And you feel free to comment on my probably suboptimal soldering style. So the idea of this board is actually that it should be possible for folks to assemble themselves if they want to. So in comparison to the main board of the MEGA65, this is all hole through. There's no SMD components here at all. So you should be able to assemble one of these using nothing more than a soldering iron, just as I'm doing it here. So it's a little bit hard for me to see whether I'm getting reflow through on those. Yep, they look all right. So I'll keep chugging away. So you're Mario saying used to be a testing operator for PCB boards in final assembly, did a lot of soldering as minor fixes required. Yeah, and it's amazing how much just correction has to be done on these things as you go along as well. So hopefully this revision of the board won't need any bodge wires. Depending how long I stream for today, I might get as far as pulling the previous revision of this board out from my MEGA65 case to put this one in. And yeah, you'll see that that's got quite a few bodge wires on it of things that we didn't know quite right. Okay. At some point I should get a fume extractor for out here. Would be good, rather than me having to blow the solder smoke away when it comes too close to me. So the again, as we're chugging away on this, this board connects to the MEGA65 rather main board using the two PMOD connectors. So that gets a 16 digital I/O line. So that's kind of the main connection, and then the internal 34-pin PC-style floppy drive cable passes through the board to get the additional signals that we need for the C65 floppy drive external port. And the only other connection it has is we actually have, again, a pass-through for the TE0790 JTAG adapter that we a number of us use on the MEGA65 to support development activities, and it's a bit of a nuisance sort of by default, because you have to open the case up to plug it in or remove it. So we've actually made it, once I flip the board over, I'll show you where it goes on this. There's a little bit of a trick with putting it in by the tape port. It turns out that we can have enough space actually for the C64 tape connector, actually being able to plug a tape drive in, and still actually have enough room for the little USB mini USB connector for the JTAG. So you end up with a really nice solution where there's nothing sticking out. It doesn't kind of visually jar, but you don't have to open the case anymore to be able to plug the USB in. So that's the connections it has. And so I've got test boards made up for those connection boards, and of course I had all the measurements wrong for the ports, very relative position, because it depends on the relative position of this and the MEGA65 main board, which I don't have all the exact measurements of digitally, so I had to kind of do a bit of measuring by hand and got that wrong the first time around. That's okay, because I can do a turnaround with PCBWay in typically 6 days. It's one of the advantages of being here in Australia, is that 4 days is typically all it takes to for the freight from PCBWay. So I think I actually did the board revision. When was it? Wednesday, I reckon. And if it wasn't for the weekend, I'd actually even have it a day earlier. But nonetheless, we'll still be here Monday. So 24 hours in manufacture for 2-layer boards, and then the 3 or 4 days for freight. So I think I'm good to chop all the legs off there. Just make sure actually that none of them have slipped out of position and look dimpy. That one there maybe that's raised a little bit. It'll just look a bit nicer if I can get that back flat again. I need to put it in the board holder for that. I'm not sure whether my board holder will actually go. No, it will if I do sideways, won't it? spinning around, and I haven't got it tight enough. Get it vertical so that I can try and get a little bit of pressure on the end of that resistor with one hand. You know, it's going to be too much of a hassle for the little bit of benefit that it is. So we'll just go back to chopping the legs off. Okay. We'll find out how many I've missed soldering as well. It's bound to be one or two. So because I knew I'd be doing a few revisions of these and testing and probably even making a few sample units to send to the folks back in Germany, I bought a bulk supply of some of the resistors and things that are super cheap if you buy in bulk. Like I think 500 resistors was $10 or something, whereas you buy them individually and they're sort of 10 or 12 cents each, which is just annoyingly relatively expensive. I probably would have got even more, but I thought the roller resistors would actually be physically larger than it is, and was worried about storage space. So if I need to get more, I probably will get 1,000 or more at a go. I just realised I was busy holding that completely out of camera. Okay, so a lot of those 1K resistors are used as, just trying to remember the layout. So we've got current limiting resistors that let us use 7.4, the HS, I think, because they're easier to get than the true LSs that are 5-volt tolerant, but actually the designer worked with both. And I've tried to make the PCB as assembly friendly as possible. So I've gone to quite a lot of effort with the silkscreen. So we've got all of the chip part names, resistor values, capacitors are all the same value, so they've just marked as capacitor, so that it's you don't have to keep looking at a schematic or anything. I just find that bit of extra effort, certainly with a hole through where there's enough space to do it, really just does pay dividends of making your life much more pleasant. And welcome to whoever's just tuned in the last couple of minutes. So we're just assembling the prototype MEGA65 expansion board. So next step, I think, is to find my 3.3K resistors, which I should have another big roll of here somewhere. Yep. How many do I need? 1, 2, 3, 4. Oh, and I still, what happened? I still missed 2 1K resistors here. So I'll do them before I get the 3.3s. Like when you pull the cutlery out of the dishwasher, right? And you think you've got all of the spoons or something, and then as soon as you turn back to it to do the next thing, you realise you've still got a couple left behind. And so I'm just bending these by hand because there's not massive quantities. If we're doing commercial production, well, actually, just we wouldn't do it ourselves. We would just pay one of the, like PCB way will do fabrication of the boards, obviously, but they'll also do assembly if you pay them. Well, I don't know what the for hole through, whether they would actually be willing to do it, or whether it would be outrageously expensive. But again, my gut feeling is I think for a lot of people actually there'll be the kind of the pleasure of building the expansion board themselves. Have I missed anywhere else that says 1K? Don't think so. And then back to the 330s, the 3.3Ks rather. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's not too many. Anyway, we'll solder down those two 1Ks and get those out the way. So we already know that all the functions work on the previous revision of this board. Or rather, I should say everything except the C65 external disk drive port. It's believed to work, but I can't find the replica 1565 disk drive that I've got, and I haven't added support in the VHDL. That said, everything looks like it should be right. I'm less concerned about that, and it might well be that the initial production release of this, we actually don't officially support the 1565, because I think that's much less of an issue for folks, apart from the fact that there is only like 3 of them in existence or something right at the moment, other than the and there might be half a dozen replica boards that folks have made. So it's my gut feeling anyway, it's much more about being able to use tape and user port and analog 15 kilohertz video out. So we've got PAL color working already. NTSC monochrome works fine. NTSC color, it's about halfway there. It's just VHDL that needs fixing. So that should be quite good. Okay, now let's put those 3.3s in. What did I say? There was 9 of them. I set the 1Ks in a really nice wide bag. That's easy to get the resistors in and out, which is great. And then the 3.3s they sent in this really annoying narrow bag that's a pain in the bum to, because the neck is so narrow to be able to pull all the resistors out. Now, how many did I say that I had? Well, it actually doesn't matter whether we get one out from the middle there or not. I think I said there was 9, didn't I? So it's 5, 6, 7, 8, 9. And sure as eggs we'll have missed one, but that's all right. So this is the first time I've tried doing the streaming of the assembly, partly because I hadn't thought about how to set the cameras up. But I should take a picture of how I'm doing this, and I'll post it on the blog at some point. The old laptop that I've got actually has a front camera and a rear camera, because you can use it as a kind of a tablet convertible mode. So I've just literally got it suspended on a couple of planks of wood out over my soldering workstation. So I'll put those pictures up after. It's kind of very zen and therapeutic to sit here bending resistors. And so the analog video output uses resistor ladders. So at the moment I'm just using the standard, each step is double the resistance of the previous step. But what we do in the FPGA is for the highest resistance step, so that's the least significant bit, we actually overdrive it at, I think we're doing 270 megs, right? And we're talking about a 13 meg signal, so it's 20 to 1 overdriving. And with that, we actually have different bit sequences we send. So we actually encode 3 bits instead of 1 with that. So we actually get 6-bit resolution out instead of 4. And in theory, we could actually do that to the other bits to get, well, in theory, 4 times 3 is 12 bits. We could probably reduce the number of I/O lines that we need, which would be nice for that 1565 expansion. If we could free up another 2 or 3 pins to the FPGA, because at the moment, the way this board works is that you've got a shift registers, is essentially what this thing is full of, and level converters. So the FPGA actually only uses 4 pins to control the physical ports. The other 12 pins that we have on the connection are purely for the video output. There's no audio output because you can get that from the 3.5mm audio jack on the MEGA65. We just didn't have enough spare pins for that. Now, which way around do I want to put these resistors? Try and make them all uniform so that the board looks a little bit nice when it's done. Do them the same way around with the gold band at the same end as I did on the 1Ks. The top of the board. And yeah, so at some point I want to do a bit more experimenting with the that overdriving and see how few physical lines we actually need, which would be nice. Okay, where's the next ones? Right, and we do gold band to the left when it's horizontal. I think I've started streaming a bit too early in the day for all the folks in Europe to get up and tune in. That's all right. We'll likely still chuck this video of this up on the MEGA65 YouTube channel once it's the stream's all done and dusted. So, I've got one more resistor left over. Does that mean that I have missed one as I've gone around? Is there a 3.3K here that I haven't populated, or did I just grab one too many out? Is it 1, 2, 3, 4, 5, 6, 7, 8, 9? Maybe I just got 10 out. I probably just got 10 out. Okay, I'll put that spare one back in the... Oh, blast. This is probably I didn't bend the legs out on them yet, did I? So they're free to escape. I'll bend those out before we get any further. So I'm curious, those of you, the 3 of you that are watching at the moment, whether you already have MEGA65s or whether you just kind of been following the MEGA65 project. Yeah, what your interest is in the channel would always be cool to know. As I think everyone knows, I don't do this for the money. I don't make any money with 3 viewers. Do it for my own pleasure and for the the joy of the MEGA65 community that we have. That it's good. It's interesting try to think about what fraction of the MEGA65 community is actually likely to want one of these boards enough to either make one or to pay to have someone else make them for them. Because so the board design is all going to be open hardware and open source. So if you want to, do the full fabrication yourself, you'll be totally able to do that. But myself or someone else might decide to offer them either in kit form, just providing all the components in a bare PCB, or possibly even offering them assembled to those who want. So yeah, I've not really been able to get a clear sense yet as to what proportion of MEGA65 owners would actually want to have the expansion board. My guess is that the main thing that people will want it for is the analog video, and possibly the tape deck, just for a bit of retro fun of actually loading from tape. If you don't care about the tape interface, it's a little bit cheaper to build because it's near where I'm soldering at the moment. There's a 6-volt DC regulator that the tape drive needs to work. So Yoramari is saying you've got a MEGA65, but have a little need for the expansion board now. Yeah, and that's fine. So speaking of having MEGA65, so as we've kind of been saying online and other places, the next batch of the MEGA65s are actually in the process of getting manufactured at the moment. So Trends Electronic are literally waiting for the I think 1,090 PCBs to arrive that they've ordered. So that'll be the bare PCBs arriving at their facility, and they will do the assembly, is in populating the boards with all the components there, and the testing, load the initial bit streams and cores on, and test all of that, pack them all up in the boxes, and do all of that process that's needed to actually get them on their way to everyone. So we're hoping that by sometime in June, everyone who has ordered a MEGA65 but not yet got one, that their orders will be fulfilled. So Yaramari is saying component video could be nice, but optimally nicer CRT shader and 4K is getting closer and closer to the real thing. Yeah, this is true. Now, in terms of what this board has for because I've been talking about the analog and composite video, we do have 3 channels on the board, and because they're being generated by the FPGA, we could quite easily change that. So we can have composite chroma and luma. We could change that to RGB analog components. We could change it to any like S video that has a CUV from memory arrangement. So yeah, there's good ways to get component video out of this board. And so Yoramari is saying, I like how old PC CRTs did the dithering, chasing that look over raster line shadowing anyway. Yeah, so it's different ways to do these things. Okay, so that's all of those resistors for which there are many of a given value. We've now got, so talking about the analog video, there's the resistor ladders here. I'm not sure why I did that one in the opposite order to the others. The other two have got 4K at the bottom and 510 at the top. This one's got 4K at the top, 510 at the bottom. So let me try and find the next value of resistor. That's right. There's the 220 resistor that we'll need shortly. There's the analog video connector. I'm just rating through my component box here off camera. What are these ones? 510 ohm. Let's do those. So the 2K and 4Ks I think I just had laying around, not in this nice mini size. The board's kind of been designed for the mini resistors, so they take a little bit less space and they just look nice laid out on there. So I need 3 510 ohm resistors, one for each channel. Okay, fold these again first. Bend them rather. So yeah, Murray, are you primarily using your MEGA65 just to to use existing software, or are you developing for it at all? Or yeah, just interested to find out how people are using their machines. Oh, okay, right, cool. So Yerra Murray's saying currently learning development, has a demo scene background, excellent. And I think, and because the bulk of us who have actually designed the MEGA65 and been making it have some kind of demo scene background as well. And one of our real goals was to make it into a machine that would, be really friendly for writing demos and kind of, feel really nice and comfortable to those that, have a demo scene background. So hopefully you're finding it pretty good and fun to work with, because of course you can just developing on the MEGA65, you can just start out developing exactly as you would for the C64 because it's a superset. Yeah, and so you're saying it's surprisingly easy to hop in and cross compile with. Yep, exactly. We've tried to make that really nice and comfortable and easy to do. And so I've been working with, now which way around should this resistor go to look best? I'm guessing it should probably go that way. So this is the feedback resistor for the 6-volt regulator for the tape. Okay, let's solder those in. That's our 220 ohm. So I like to just do all these resistors and get them out of the way before I do the IC sockets. I just find it to be a little bit easier that way. Because I'm always wanting to bend these legs in funny directions. And so some of them, if you've got the sockets and legs poking through, it's just a little bit of a, I find anyway, a bit of a less optimal way to work with it. Okay, that should be those. So the this is revision D of this board. The revision C one, which is the previous one that I made that's described in the blog post. There's the little issues that we had the bodge wires for have all been fixed. All of these big mounting holes are now in the right place. I did realise I still missed one. There's actually on the MEGA65 another hole kind of near the end of these pair of resistors. But the way it sits there, it shouldn't interfere, so I probably won't bother putting that in. I mean, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 holes to hold it in still. In reality, by the time it's connected with the two P mods down the front, and then this other bridge board that goes over the top, I'll grab one shortly and kind of show you how that will fit in. That will be anchoring the board over here and down here on a floppy connector, and over here in one of the 4-pin power connectors across to the MEGA65 main board. With that alone, probably actually the board can't move, and then you have this PMOD little board that goes across, bracing it there. I don't think that there's going to be a lot of trouble. So Yaramari is saying, I like working without the emulator, so now with Etherload I can set up full memory map for a single effect by loading a memory block at the time and just calling my entry. Yeah, that Etherload stuff, I was so glad. I can't remember the username of the guy who did that work to get that working and to fix the remaining bugs in the Ethernet controller on the MEGA65, but it is just so nice now because you can load it. You know, I mean, in principle, you can load it well over a megabyte a second. So yeah, it's really nice. And then you remember I was also saying the raster rewrite buffer and DMagic are just asking for a lot of nice effects to be made. Absolutely, and that's kind of part of the intention of those. The raster rewrite buffer, I was actually really pleased with as an architectural idea for the MEGA65 when we kind of looked at the bit planes on the C65, and they were, I mean, in one sense they were really groundbreaking, right? Because this was a machine being originally designed in 1987 was actually when the C65 started being worked on, 86, 87. And to have 8 bit planes on a machine back then was just crazy, right? I mean, this was well before the AGA Amigas came out. Unfortunately, the bit planes on the C65 have a few significant limitations. So one is on a machine with only 128K, you don't have room for many bit planes, which is kind of why character-based graphics rather than bitmap mode on the C64 was popular. Partly it uses less memory, and as a result, updating the display takes a lot less CPU time. And so with the C65 bit planes, you couldn't move their addresses finely in memory like you can on the Amiga, so you didn't get hardware scrolling of them for free. So you had to kind of update them all in one go. And okay, you got the DMA controller, which is a great advantage for that. Unfortunately, there aren't enough cycles in a frame on the original C65 to be able to move all 8 bit planes every frame. So you'd have to, you couldn't even drop the frame rate, right? Because if you drop the frame rate, then you didn't have room for double buffering, which you would need if you were going to just move some bit planes in one frame and then move some in the next frame. So it was, unfortunately, quite challenged in terms of the usability of the bit planes, which is, as I say, a bit sad. So we had focused on the character-based improved modes on the MEGA65, which kind of felt more of a natural follow-on from the C64 anyway, with the VIC-2 being really all character-based. So actually the early development of the MEGA65 and VHDL didn't even support the bit planes. They only got added in relatively late in the piece. We can't, I'd even originally repurposed the registers for other things. But we've added them in for completeness. And the C65 ROM, of course, uses them for the basic graphics, and it's about the only thing that that I'm aware of even uses the bit plane graphics on the MEGA65 is the C65 ROM. It'd actually be great to update the C65 ROM's graphics routines to use the new improved modes. So the 256 color full color mode, and as Yaramari was saying just before as well, that they love the NCM nibble color mode because you only need 4 bits per pixel, which saves more memory again. So yeah, you'll be able to have a 16 color nibble packed display. And at some point we actually need to improve the DMA controller to be able to do the hardware graphics line drawing in NCM mode. At the moment it only supports it in full color mode. So yeah, cool. There's our 4K. So these were the full size resistors. I didn't have the little ones, so they're having to be angled up. Not sure whether you can quite see. They're standing up a little bit proud off the board at one end in order to fit. Now, I think I've got 4K resistors hiding in this other bag here somewhere. Otherwise, it's just a test board for me. I don't mind terribly if I have to do 4K 7s or something like that. but I've got 4K resistors here. So it's funny what's in stock and what's not in stock with the all the global supply chain carry on. I couldn't get normal looking resistors in 4K. They're these funny little brown blob jobs that look quite different to all the rest. So I guess 4K is a little bit of an odd value. There's no reason why we couldn't actually, again, do a tweak of the next revision of the board so that we get rid of the 4K resistors, because they are a little bit of a pain to get hold of, and replace them with two 2K resistors. I mean, in theory, we could do it all with lots of 1K and a single 500 ohm resistor, but the board is a little bit too busy for that in the area, I think. Because you really want to do the digital to analog conversion as close as possible to the connector, so that you don't pick up as much noise, because while it's still at 3.3 volt, it's relatively immune to low voltage transients being picked up on the lines. But once you've dropped that down to a fraction of a volt, or right down into the millivolt range, potentially depending on the impedance in the monitor, that's going to be much more prone to picking up interference. And howdy to whoever's just joined. So we're just assembling one of the MEGA65 expansion board prototypes that I've been working on. Just putting in the last resistors for the 15 kilohertz analog video output. So obviously, if anyone has any questions about the expansion board or anything MEGA65 related, do always feel free to chuck it in the chat, and quite happy to give answers while I'm doing the assembly here. And if you see that hey Prowl7, if my technique is looking particularly bad in any way, feel free to correct me. I'm kind of self-taught for the most part on soldering and a lot of electronic stuff, so I'm always keen to learn better ways to do things. Okay, so I think that is all our resistors. I'm actually not going to put this is the first revision I've put provision for decoupling caps in. So I'm not going to fit those until I've actually built it and tested the board. And then once I've tested it, then I'll put them on, and then it will presumably still work, and that'll be good. Rather than if I put them in first, and if I've somehow screwed them up, then I won't know whether it's some other issue with the this revision of the board. So I reckon it might now be time to start sticking some chip sockets in. Got my little drawer of IC sockets down here. Got two different sizes that we need to attend to here. So I've tried to put, I'm not sure whether this kind of comes through on the camera or not, I've tried to put the part names in the chips in the middle, so that even once you actually put the socket in, you can actually still see what chip goes where. And of course I've got them all facing around the same way, so that there's no bad surprise from fitting a chip in backwards. Let's see whether I can put all of these in and then flip the board over without them falling out. Why is that one not going in happily? I've only got 4 of those on here. Maybe I have only got 4 of those. Yep, it's a 74LS125. So they're open collector drivers from memory. Might need a bit of blank PCB or something to hold this still with. So spare bit of PCB is one of the prototype updated, well, alternative version of the MEGA65 keyboard. So, for example, if you're using a Nexus 4 DDR board, you can actually build up your own MEGA65 keyboard. And if you want to do it cheap and cheery, you can then just get the those vinyl sticker sets with the Commodore keys on there. So this is the fully working MEGA65 compatible keyboard built up at home. So let me use that to hold the IC sockets in while I flip it over. And one of them is different. Yeah, 3 of them are falling out. Right, okay. Maybe I will just swallow my pride and stop wasting time by trying to be over efficient and just put a single one in at a time. And I can just tack a single pin on that. And then I can flip it and do the next one. If I only do one at a time, I can make sure that the socket's in nicely without strain. Now I can tack the other corner. And I might as well just solder them one at a time and then just done. So partly it's just kind of fun to stream these things. Part of my goal as well is to give people a guide when they're assembling their own of these down the track if they want to. To see how it's done, or rather how it can be done. And I'm sure there's people who are actually much more capable at this kind of thing than I am. And so you can kind of see that even someone who's actually a little bit basic in their soldering skills and abilities can do it. So I'm holding here now to try and get the pin all the way through in the hope that that socket is now sitting flat and lined up on there, which it is. So I'll do the opposite corner so that it can't move. Make sure it's still flat and level, which is good. Now I can solder the rest of the pins. So I'm hoping that this revision, revision D of the expansion board, will have all of the remaining issues fixed in it. And it will only then be cosmetic changes if we decide to, needed before people can make their own. So the MEGA65 core already has partial support for this board built in. And the next update after the version 0.96 update, which was the one that will be coming out with the next batch of MEGA65s around the middle of this year, or by the middle of this year, we expect, that we will include full support for this board, so that the tape and user ports and everything will all be active. It was pretty fun actually, loading a game from tape for the first time on the on this board. I did quite a lot of testing through simulation in VHDL for this board, which paid off quite nicely. Meant that when I actually went to implement the support for those ports, that they did largely just work. I had a couple of lines with inverted voltage sensors compared to what was expected, but they were pretty easy to deal with. And of course, now that I've got the nice FPGA build machine that can synthesize the MEGA65 VHDL in about anywhere between it's typically about 11 minutes, but sort of 10 to 13 minutes is not atypical. That it's it's quite fast to then iterate on these sorts of things. At some point I might put faster RAM in it, because Dan has the same CPU, so it's an Intel i13900K, and he gets build times that are close to twice the speed, and I think it actually comes down to having lower latency RAM, because FPGA synthesis is quite heavy on random memory access. Now for the life of me I can't see where the fourth one of these, there it is. Yep. So once I've got this all soldered up, I'm actually just going to take the ICs out of the sockets in the revision C and switch them over. Now there is an exception to that. There's a couple of the chips up here by where the floppy cable goes, where it's really tight if you have them socketed. So I will actually directly solder those two chips in, as I did on the revision C prototype. But all the rest of the chips I'll have socketed. Okay, let's try and get that in. Yep, that's looking good. I'm going to need a new roll of solder in a minute too. Fortunately, I've got one here. Yep, that's looking good and flat. Do the rest of it. It should be interesting to see, because the C65 ROM at the moment, and including the C64 mode of it, actually lacks tape support, because I had to take the tape support out of the C64 mode to make room for the code that talks to the internal drive DOS, and also does the initial detection to decide whether to boot up in C64 mode or C65 mode. Because I don't know how many people are actually aware that a C65 actually starts up in C64 mode, and they've changed the SYS64738 entry point. Instead of being FCE2, is now a different location that checks if the Commodore key is being held down, and checks if there's a cartridge, and if either of those is true, then it will stay in C64 mode. Otherwise, it will escalate up to C65 mode. So yeah, it's a little bit like how the 128 actually starts in Z80 mode and then actually switches across to the 6502. So like in theory, the mode that was intended to be used most frequently is actually not the default mode on the two successors to the Commodore 64, the 128 and the 65. Let's see if I can't actually hold more than one of these in place this time and flip them all in one go. I'm hoping it'll be easier now because we've got other sockets in place there already. Okay, let's give that a go. And welcome to whoever's just tuned in. We are assembling a prototype MEGA65 expansion board here for me to test the latest revision. For those who hadn't already noticed, I'm left-handed. And they're mostly flat. That last one actually is at a bit of an angle, so that's why I only do one pin initially, because I can then just hold the socket in. Hey Dan, welcome aboard. Great to have you with us. So I think you know what this is, don't you? You've seen some of the discussion around. You're an hour late. Yeah, you are an hour late. That's right. Fortunately, or unfortunately, however you want to look at it, it takes me quite a while to assemble one of these, especially sort of, you know, something to do for a bit of fun, right? So it's kind of, you know, at a more sedate pace than if it was my day job to do. I think if I was going to make these up to provide people with fully assembled ones, we would just use one of those assembly services, because it would be this many holes for a hole through. For those who've followed the adventures of the 8-bit guy recently with the Commander X16, and you know, the effort that they went to try and, you know, set up an old school hole through auto soldering setup. It's actually really hard. Like, you know, the boards warp as they heat and get dunked into the solder bath, and just, yeah, all sorts of complications. Yeah, Dan saying looking forward to assembling on his own if we do it as a kit. Yeah, and I think that's probably for a lot of people the way that they'll do it. It will be much more cost effective for people to buy it as a kit, and you'll kind of, you know, get that fun of you know, of putting it together yourself. And because it's all hole through, it really isn't, you know, in my view at least, particularly troublesome to solder. And particularly, I mean, if you put the chips in sockets like I'm doing, the risk of you frying a chip from, you know, bad soldering technique is quite low. And if you kind of, you know, leave those two chips that you have to, well, you don't have to put them in without a socket, but it would just be quite hard to do without a socket. I think I can justify myself in opening the new solder roll when I've got only half an inch of solder left. So for this home stuff, I'm just doing it with leaded solder because it's so much easier to work with than the non-leaded, and that would certainly be a recommendation if you are building this at home as a kit. That the leaded solder is much easier to work with. Just, you know, you always make sure that you wash your hands before you, you know, eat or pick your nose or anything afterwards, right? Just a bit of tape. Now, I don't know whether this is the same thickness or whether this is thinner solder. It's probably the same. Okay, let's feed it onto the... Oh, blast. It's a bigger roll. It doesn't fit in my dispenser with the bodge wire. Might have to get a second dispenser. Oh, goodness gracious. Yeah, that was pretty old solder. That's probably why it's not exactly the same size. It's taken me, I reckon, 20 years to get through that roll of solder. But going through it much more quickly these days, working on this kind of stuff. Okay, let's continue on. The other reason I like to put more than one socket in at once is I do find, and maybe it's just as a thing as I'm getting older, that the brain works better if it's doing the same thing repeatedly rather than chopping and changing back and forth between things, right? It's the whole why production lines in factories are more efficient than having one person do every job on a single item. And I'm sure anyone who is actually an expert in soldering is probably going to be cringing at my style, but the only thing that I'm probably doing right is try to make sure that I heat the pin and the pad at the same time. So I tend to put a little bit of sideways pressure on the pin with the iron trying to touch the pad. All right, let's have a quick look there. So that's 3 of those big ones. We've got 2 more there to do. The video connector and the 1565 floppy connector ports are actually good to do kind of right at the end because they're so big and tall and chunky. Once you've got them on, you really can't put this other shorter stuff on as easily because the board's sitting up at a weird angle, right? So you definitely don't want to put them in before you solder in all the sockets and the ICs that you're going to fit directly. It's going to Dan is saying, I still don't know if my soldering technique is reasonably okay. I can't tell if I'm using too much heat or not enough. This is iron adjustable. So I've got this one set to 310 degrees centigrade, which, again, I don't know whether that's ideal for this or not. Probably other people will be able to comment once this is up on YouTube about better settings for the iron for this. But I find that the 310 works quite fine. I'm not. If you have it too hot, the risk that you have is of scorching the board and delaminating it and stuff primarily, right? And frying sensitive components. Not many components that are 5-volt hole through are, shall we say, particularly sensitive. And there's one pin I've missed. But I suspect, because I can't even remember what the melting point of the solder is, but you could probably go down to 260 or 280, I suspect, without any trouble at all. For example, but again, if you're not holding the iron on the board for heaps long, then it doesn't matter if it's a little bit hotter, because of course when you actually touch the iron, the heat's now flowing into the things. Look, I'm streaming. Hang on a second. Let me just pause things here, folks, for a second. Who knows how I can do that. We'll be back in a minute.
Ages ago. It was on the phone, waiting.
just need to quickly grab something off the computer for my wife, who's going to look at. It's actually a grant that I'm putting in for some support for work on the handheld version of the MEGA65. Print to file. So I'll get that in there. My wife has very kindly agreed to have a look over that to help make it the best it can be. So I'll just be back in a couple of minutes once I've chucked that out on the printer. Okay, and I just need to quickly print out the grant information. Because if this is successful, I can get enough money to actually be able to work full-time equivalent for several months on the handheld MEGA65, which would be pretty cool. Okay, we're nearly ready for me to attack the soldering iron again. I'll just quickly make sure that my wife's got that stuff inside all right, and I'll be back out in a moment. Okie dokie. Right, where did I get up to? What needs to go on next? I think I will solder those two chips in next. So these are the ones that, as I said, you can socket them, but then you make your life harder in terms of getting the floppy cable in. Now make sure that's the HC165. Now ideally I wouldn't be touching the pins on these, but the risk is relatively low. The other trick that you need to do is the spacing on the board versus the spacing on the chip legs as they come by default is narrower, so you kind of have to bend the pins in a little bit to get them to go. So one approach is to put the pins in on one side and then kind of squish it gently a little bit. This is kind of, in my view, the fiddliest part of the whole thing. And you can then do that on the opposite side of the chip to bend the legs on the other side in a little bit. But it really is only a relatively small amount. It's only sort of a few millimeters that needs to come in. Now I'm just using my thumb on the other side to kind of get them to go down into the holes. On the upside, once it's wedged in there, it's not going to fall out very easily while you flip it over to solder. Again, I'll just do one pin and flip to make sure it's still sitting nice and flush. Yep. Should probably fix these footprints being on the wrong side of the, or the silk screen rather, for them being on the wrong side of the board. So is there anything that anyone would like to know about the expansion board or the process of building it that's not immediately obvious while I'm just quietly soldering away here? Dan's asking, are any of the parts rare or unusual, or are they all conventional parts? So the vast majority of them are pretty conventional. I mean, supply chains make things a little bit tricky for some things. So before you came on, I was sort of saying that I couldn't get 4K resistors in a normal type, so I've got these weird brown ones. Who cares? The other thing that's a little bit tricky is the 6-volt regulator for the tape motor controller. But there are a variety of interchangeable variants of that. It's actually the single most expensive component, like $15 or something. So if you don't need the tape drive, you can skip that. But otherwise, it is all pretty straightforward. We'll post the bill of materials and part numbers on for somewhere like DigiKey to make it easy for people to order parts to make themselves. So yeah, there's nothing too troublesome. This revision has, well, actually, and it was done on the revision C, but it's of course on this revision as well, the revision D. Previously required 7.4 LS chips for some of the 5-volt tolerant stuff, but that they were quite hard to get and quite expensive. So instead I put the current limiting resistors in. That means you can use the 5-volt tolerant but 3.3 volt fed version of the chips that is much more easily available. So the oh goodness me, it's HVC or HS. I can't remember the exact thing. It'll be on the BOM list. And in small quantities, some of the, like the headers, like for the floppy connectors and stuff, can be a little bit expensive, but nothing too troublesome. Okay, so we've got our 2 chips that have to be soldered in. So now I will start adding in all of those headers and things. So I did a while back, ordered direct from China. Like I've got a whole box of edge connectors and things which come in super handy. Unfortunately, I didn't order all the sizes that I would have liked. So for example, for the PMODs, I have to trim these down to length. That's okay. But I do have, when I find the right little baggie of them in here somewhere, the 34-pin floppy connectors. I thought I had the exact right size somewhere. If not, I can, yes, here they are, 2x17s. So we need a pair of those. And then we need 1x4, 2 lots of those. And so these are a little bit entertaining. One of those I'll show in a minute. It's a bit fun to do because you have to cut a pin on it. Except actually, I have to remember what gender they need to be now. Yes, they're male. That's right. It's on the connector board that they need to be female. Because the T0790 connects on this one, so it hangs out with the port on the user port, and the T0790 has female on it, so it needs to be male on here. Okay, how well understood are the electronics for the 1565 drive considering it was unreleased? Is there a chance of needing to revise the expansion board if when we clone a 1565 board, or would it make more sense to just make the clone compatible with our expansion board? Yes, so that's, I was saying earlier in the stream that is something that is totally an issue. I've designed it so that it should actually be able to be compatible, but the limitation of making the board kind of in this cheap way using the existing expansion connectors on the MEGA65 does mean that the rate at which we can do the signaling to the 1565 connector for some of the signals is quite low. It's sort of in the kilohertz, tens of kilohertz maybe range. So that's going to, we'll have to see whether that's sufficient. If it's not, what I'm hoping is that, again, as I was sort of saying earlier on, that we can, oh blast, I need to just do one pin first because I need to then get it to sit level. Right, now we do the other one. Yeah, to get the shift, because it's actually a shift register interface on the 1565, not dissimilar to what I've done on this board. That the 1565 users. So yeah, there's a good chance that this board will work without further revision with it, but it would actually be really good for us to make our own clone 1565 controller board sooner rather than later, so that we can then check that. I just noticed that those two connectors are actually not perfectly lined up. Not that it matters. Okay, lots of fairly repetitive soldering now. "64 pins to be soldered." So designing that board for a 1565 actually wouldn't be that hard. It can be done with 4 glue logic chips for the most part. Particularly, I think the sensible thing to do for the MEGA65 at least, because all modern PC 3.5-inch drives don't need 12 volts, is to actually not need it to have a separate power supply. That we should be able to run enough 5-volt current over the 1565 connector itself, so that you wouldn't need a separate power supply. Because that's kind of one of the annoying things with the 1565 is that it does need a separate power supply. A 1581 compatible power supply is what they used. Obviously, we wouldn't have to do that if we didn't want to. You could use something different, but even better if we can just not have one. Because a modern 3.5-inch drive, they're only, I can't remember the maximum power draw, but it's most only a few watts, and so at 5 volts, we're talking hundreds of milliamps. Nearly there. Oops. Okay, that's by far the 2 highest pin connectors. I don't think I need to sneeze. Oh, sorry about that. Oh, I can feel that's warmed up the ground plane quite a bit. Okay, let's do the easy connector for the 790. Can I just tack this with what's on the soldering iron? It's kind of, I reckon that might be enough just to hold it there for me. You see the funny angle that's at. So I'll just press that from the back to get it into the right spot while remelting that single pin. Just remelt that just to take any tension off it that might have been on there. Okay, now it's sitting nicely. All right. Okay. And hello to whoever's just joined in. Okay, so that one's on. Now we've got this other fun one. So because we've allowed for a different variant, and actually after I rearranged things, actually now we probably can have the original missing pin back in, but I haven't. So we just need to snip that pin. So there's an unused pin on the TO790. So now that can sit in there just fine. So let's get that. Anchored in. So for whoever's just joined in, we're doing the assembly of the next prototype MEGA65 expansion board. Now the other header that's here would be if you're using a TI 004 instead of the TO790. So I'm not going to bother populating that header. You'd only populate that and not populate this one if that's the JTAG adapter that you were trying to reuse. And the board, as we were saying earlier, just relays that through. So it's literally just this connector and that one are connected to each other and connected to this one here. That then the connector board that goes to the MEGA65 actually connects that to the TO70, 970 socket rather, on the MEGA65. Now, as I said, I have to trim these connectors down. You want to do this with eye protection. My recommendation is just don't buy the wrong connectors, right? And then you don't have to worry about this at all. Okay, it's a little bit ugly on the end, but it works. If you do have to do them, what you want to do is kind of cut in line with the first pin that you don't need, because that guarantees that you don't damage the pin that you do need. And you can kind of, like I'm doing now, you can trim it down a little bit more if you need after. But because of how these sit, it's actually really not a problem anyway. Now, hopefully, they will, again, we'll just use the trick of using the spare bit of PCB to help them sandwiched in place. We'll just make sure that they're oriented correctly. Yep, so that one, good to check because that one's a bit funny. So again, I'll melt those two pins back to take the strain off of that, and then it will happily sit flat correctly. I just realised the camera aimed up at the roof rather than down at me for the last while, haven't I? There we go. And welcome to whoever's just joined in. Again, we're assembling one of the prototype MEGA65 expansion boards. Getting towards the end of it now. I think I've actually decided I'm not going to pull the chips out of the previous one. I'll keep them in there because I know it works. And then if I need to compare things, I can. Okay. Righto, it is now getting pretty close. I need to put the video connector in, I need to put the power regulator and populate the chip sockets. DigiKey. Wrap these up quite nicely actually. Make sure they can't fall off the well, it needs anti-static foam, but the foam's really just there to stop the pin legs getting bent, right? So make sure I bundle that up nicely but go back in there. Righto. So this one again is a little bit of a pain to keep flat, so we'll just do one pin first and then we'll flip it sideways and make sure that it's all sitting straight. Yep, that's looking all right to me. Okay, that is nicely fixed. Might just reflow that one just in case. Looks fine, but not sure. Okay, so we need the DC-DC regulator. Now, that component gave me a little bit of trouble before because it looks like it should have pin 1 on the opposite end to what it does. Where is it? Oh, and I might actually put the previous revision I didn't actually put the 1565 connector on, but I think I will on this one because I do want to just make sure, because I did shift it slightly sideways. DC-DC regulator. As I say, these are the most expensive component. It's like $10 US, maybe even $12 US or something. So I won't pull him out until I've double checked inside on the existing one which way round is the right way round. But I'll just chuck the 1565 connector on first. Righto, so that holds in nicely by itself as well. Again, we'll just do one pin to begin with. This is a little fiddlier to solder because it's not quite 1/10 of an inch spacing. Ordinarily, if I was assembling this to have that, I'll put that on first so that you don't have this big thing in the way to stop you being able to have a little bit of just gravity pressure on that when you sit it on the bench. But as it is, it's gone in fine. So and so it must be said, the couple of people that have supported me using ko-fi.com, coffee.com. That's by no means required, but it is very much appreciated and just helps to pay for all of these consumables as we go about developing different things for the MEGA65. So very much appreciated. And that's just, I find really lovely because it's just part of the community spirit with the MEGA65 community that we kind of, we're all in this together, making this machine physically and as a platform, and the titles and things to run on it. It's a little bit of reliving the 1980s all over again together. MEGA65 in that regard is a bit of, if you like, it's the fractal C64. It's the next iteration of detail in. Okay. Oh, I've got the two power connectors here as well that I need to do. So for those, I've just got some strip, and I'll just cut 2 4 long pieces of that. Oops. And hopefully not break a pin like I did just then. Again, I probably should have done these before I did that, the other connector, because again, it's just going to be a bit of a pain to hold those in. What I might do, what I need to do as well is because I'm holding my fingers on several of the pins on the back, but not the one that I want to solder. Otherwise, that finger will get very hot very quickly, which will be quite unpleasant. I'm trying to sneak here just to get the solder where I want it to reflow that connector. Right, that's one of them done. And we'll check their orientation in a minute from on the top. Okay, let's have a look. Yep, you can see doing it like that, how wonky they've ended up. That's okay, because I can reflow the single pin till it's sitting in flush. Yep, they look much better now. Let's finish soldering those on. And I'll quickly go and get my MEGA65 dev board from inside so that I can see which way around that regulator needs to go. And then it will just be chucking the chips in. So back in 20 seconds. Okay, back again. Phone's back on. Righto. So, I grabbed a couple other things while I was in there. So we can see here on the dev board, so that's the voltage regulator there. So we can see it faces with the components on this side. And behind it, that's the T0790, the JTAG that would normally go on here on the MEGA65. And whoops, if I tip it up, you can see it just poking neatly in the corner of the tape port, and there's enough room to actually still plug in the tape drive. Now, because this is my the dev version, so it's all crazy cables connecting it. That's not going to be the case. What we have is this bridge connector that you kind of see. It'll go over the TE0790. It'll go over the floppy connector, and it'll go over one of the power connectors on the MEGA65. And then it goes over the TE0790. It'll be easy to see now on the on here. It'll go over that and over the floppy connector and over power connector. Now this one has incorrect measurements. You can see I've marked up all the corrections that are being fixed and the ones that are being shipped to me at the moment. So that will just connect all of that together. And then the PMODs on the front. This is a little board again. The measurements are wrong, so I've only soldered one lot of pins on here. It will go into both the pins there and into the pins of the PMODs on the MEGA65 and join it all together. So it will look really nice and neat and tidy with no cables at all, which will be great. So I'm going to put the MEGA65 out of the way so I don't go soldering my case up. That would be bad. And we said the components go on the left-hand side. This particular model of DC-DC converter is quite nice in that it very firmly fits in the hole, so you don't have to worry again about it falling out while you're soldering it, and it's short enough that the case can still shut. One last double check. Okay, yep, we're good. Let's solder that little sucker in. And welcome to whoever's just joined in. As we put the last bits of solder on this MEGA65 Expansion board prototype. Now, some of these pins can take a little bit longer to reflow because they've got thicker traces connected to them. And so now here's the first one I've bridged as well, right? I'll unbridge that in a minute just because it is quite snug with these big fat pins. So I'll just get a bit of solder braid to de-bridge these in a minute. It's kind of better to start with them bridged and know that you've got a good solid connection. Oh, some braid. There we go. Snip the end off that. So just a conventional little roll of desoldering braid, and this will just wick up the excess in there, and hopefully make it really easy to de-bridge them. The challenge we've got with all of those pins bridged is that their joint thermal capacity will be fairly high. So it might even get a bit sneaky. Do one sort of halfway through. And I'll visually inspect those in a minute and make sure that they're still soldered, but no longer touching. Okay, they all look good to me now. I'm just going to trim a couple of these other resistor legs from where I put them on if they're near a hole or anything that's going to cause me grief, and just double check everything. And looks like I might do with a bit of a reflow. It's pretty common when you make these sorts of things that there'll be something somewhere that's not been flowed correctly, or like this, you realize that you haven't soldered an entire side of an IC socket. Okie dokie. So that should be everything now except for putting the chips in. And as I said at the beginning, I'm purposely not putting the decoupling caps in yet because I want to test it without that and make sure that they're working fine, and then I'll put them in and make sure they're still fine. The other thing you'll notice is that the heatsink, there's a heatsink footprint here for that DC to DC converter because this is a little switch mode version. But there are non-switched mode, if you like, analog old school ones that do actually have a heatsink that goes onto the ground plane there. So, but it's not a drama if the ones that you get are vertical like that one. Just chuck them in, it'll be fine. Okay, let's put some chips in, and then we really are done. Okay. Right, so these are the 595s, of which we need 1, 2 more. 1, 2. And we've got all the pin ones all line up in the same direction on this board. Oh no, there's 3 of them, that's right. And again, the pins are wider than the sockets, which is quite normal for these chips. So I'm just using my thumbnail to hook them to the point where they'll actually go in the socket, and gently pushing the body of the IC across a little bit so that it can bend the legs on the other side enough that it can all go in. And I'm complete nincompoop. I have put the chip in backwards. You can see the notch for pin 1 on the wrong side there. That's annoying because I can't find. I have got a chip puller, but I've got no idea where I've put it at the moment. So I'm just going to have to delicately lift it with a flathead screwdriver. And I can't even see where my little flathead screwdriver is, so I'm going to do it with a big fat chonkin one. That ain't going to work so well. Caught up with the Braymac people recently, who've been quite kind at providing sample parts and things. And one of their nice little trade gifts was this little screwdriver set. It's got magnets to hold everything in, and a nice little driver. So that was a nice little gift from them. That would come in very handy just now. I'm trying to prise it gently from end to end so that I don't end up with any bent pins. And I don't care if it takes me several times at each end to do that, because it's better than a wasted chip. It should now come out, hopefully. There we go. Righto, let's put this sucker back in with pin 1 at the correct end. Righto, 2 down, and said that she needed 3, not 2, so I'll get the extra one out. Oops, not that many. Just making sure I'm still putting the right model chip in. And I've folded the legs in a little bit too much on there. Straighten them out by hand a little bit. Okay, that's looking good. Now the 165s, we do only need 2 of those, so I'll get those. That gets a little bit more fun as you start getting more of the chips in near one another, right? Yep, I've got pin 1 at the right end. Did one around the wrong way last time too. Okay, now we've just got the 125s, and we have 4 of those. One, 2, 3, 4. And welcome along to whoever's just joined. The finishing stages here of assembling this prototype MEGA65 expansion board. Just putting the last 4 chips in after we've soldered everything else in. Until I try it out and discover I've left something out. Okay, it's in, and pin 1's at the right end. All the legs are in, got a good firm squish. And pin 1's at the correct end, yep, okay. Right, and the lucky last one. So the other thing that I did with this board, rather than pay PCBWay a lot of money to do it, is I manually filed the bevel onto the user port and tape connector. So that just helps to improve the life of the things you plug into it. So it is well worth doing. And it was just a couple of minutes with a file, just gently rasping from both sides to get it, so that the end profile is no longer just a rough square. Okay, I don't think there's anything left to do here other than to take it inside, plug it into the board and try it out, but that will be on a different stream or in a different blog post. So yeah, thanks everyone for tuning in. Hope it's been a bit of a zen watching that all happen and listening. And Dad's like, oh, I want to see it work. Yeah, I can't do that from here. I have to go back into the other streaming setup, but maybe in a few hours' time. But what's kind of nice is that's taken me just under 2 hours. It's 1 hour 58 on the stream, from bare board to fully populated, with the exception of those decoupling capacitors, which shouldn't take more than 5 or 10 minutes more to do. So something of the order of a couple of hours. If you've got some reasonable soldering experience, seems like it should be doable, which is good. So yeah, so thanks again for tuning in. Hope that was enjoyable, and yeah, we'll catch us around. Oh, sorry, so Zensos is saying, I'd like to see the connector board. Yeah, so let me show you that again. So there's two connector boards. The first is the one that connects to PMOD, so that's this little thin job here. So again, this one is the wrong measurements. The corrected version I have in the post at the moment. So you actually if you have a look, you can actually see that the second PMOD doesn't line up. It's out by about a hole. But the idea is that when that's sitting in the case, you'll just be able to push that on, and it will mate into the two PMOD connectors on the expansion board and the two PMODs on the MEGA65 main board. So there's that half, and then the other half is this one that will go, and again, there's been some corrected locations of connectors. So that will all mate up on the floppy connector, on the PMOD connector, on the power connector on here. And then onto the floppy connector, power, and JTAG on the MEGA65. So Dan is saying, is the JTAG USB in this build? No. So for the JTAG USB, you will still, and I can actually show you that. I think I can pull this one out from the other one here and show you. So you'll still need your T0790, but instead of connecting onto your MEGA65 main board, you will connect it onto this header. And that connector board will relay, so that is connected to here, and then the connector board relays that to the T0790 socket on the MEGA65 main board. So this was the cheapest and easiest way to do it, but it still gets that really nice improvement. And I think you might not have tuned in when I kind of showed how that looks out the back of the case. I'll see if I can just quickly show that again. Just need off camera to squish it back into the other one, which is a little bit interesting to do. Right, so what you see through the tape port on the MEGA65 when it's all fitted is like this. You've got your tape connector and you've got the mini USB for JTAG, and there is enough clearance that you can actually plug both of those in at the same time and and unplug them freely as well. So I actually really like it because you've got your your USB is as easy as if it was in a header somewhere, but you don't kind of have the nostalgia jarring. Yeah, for me anyway, having a USB port for that. What Dan is saying, surprised by the connector boards, is that really better than ribbon cables. So the ribbon cables are actually more expensive probably than making the connector boards, because the connector boards only cost probably a couple of dollars each, maybe $5 with the headers on them. Whereas the ribbon cables would cost more, and the ribbon cables are a bit of a pain in the backside to fit in the case, because they want to spring up, and particularly for the P mods where it's really squished in close by the keyboard, it would just be really quite hard to do with the ribbons. And the connector boards just look way nicer in my view, rather than having the the cords everywhere, because you would end up with two cords, like two ribbon cables, one each for each of the P mods. You would then have another one for the floppy to the floppy, and then your regular floppy cable to the floppy drive. You would have another one for the JTAG to there, and another one for the power. So you actually end up with a lot of cables, which is why I decided that was just a pain in the backside. And it was probably actually for me for during development, because trying to mess with those cables is actually really annoying, because I didn't have pre-made cables, so they're all just individual one-pin things, and make sure they're all lined up. So that'll take me the most time in getting this ready to test now. So yeah, but anyway, we're there. And I will sign out now, and I'll go and see if my wife needs any of my input to help with that grant that we're hoping to put in to be able to get some financial support for the handheld development, and see how it goes. So thanks again, and